Hello and welcome to Dr. Anima Upadhyay's Chemistry in Technology and Chemistry lecture videos. The topic of today's video is DSC studies of Chalcogenide glasses. This video I am making on request that I have received from many researchers and postgraduate students who are working and learning in this area. But before I start this video, I would like you to please subscribe to my channel if you have not done it so far, and also to share this video among your colleagues and friends, because I believe that knowledge should be shared. Now let's begin this video. I have formatted this video in the question answer format for better understanding of the subject. Let us begin with the full form of DSC. It stands for Differential Scanning Calorimetry. What is the principle behind DSC? Explain with the help of examples. DSC is a thermal analysis technique in which the heat flows into or out of a sample and is measured as a function of temperature or time while the sample is exposed to a controlled temperature program. The explanation is simple. When a sample undergoes a physical transformation, such as phase transitions from solid to liquid, either more or less heat flows into it than the reference to maintain both reference and sample at the same temperature. The amount of heat flows to the sample depends on whether the process is exothermic or endothermic. Now let us understand it better with the help of examples. When a solid melts into a liquid, it requires more heat as it undergoes the endothermic phase transition. Therefore, it requires more heat to the sample to increase its temperature at the same rate as the reference. This is due to the absorption of heat by the sample. Similarly, when a sample undergoes exothermic process, for example, crystallization, less heat is required to raise the sample temperature. By observing the difference in heat flow between the sample and the reference, differential scanning calorimeters are able to measure the amount of heat absorbed or released during such phase transitions. DSC may also be used to observe more subtle phase changes such as glass transition temperatures, abbreviated as TG. What is DSC technique used for? DSC is a thermal analysis technique to measure the change in the physical properties of a sample along with temperature against time. Thus, it is used as a powerful tool for the identification of various physical properties, thermal transitions, and composition of polymeric materials. What are the applications of DSC as related to chalcogenide glasses? The main application of DSC is in studying phase transitions such as composition, melting point, glass transition temperature Tg, exothermic decompositions, sample degradation. These transitions involve energy changes or heat capacity changes that can be detected by DSC with great sensitivity. It is widely used in industrial settings as a quality control instrument due to its applicability in evaluating sample purity and for studying polymer curing. How are the results concluded by DSC studies. The results of the experiments performed by DSC are plotted as curves. With the help of these curves, the results are deduced and concluded. Explain a DSC curve. The DSC curve is a heat flux versus temperature or time. This curve is used to calculate enthalpies of transitions. It is done by integrating the peak corresponding to a given transition. The enthalpy of transition can be expressed using the equation delta H is equal to Ka, where delta H is enthalpy of transition, K is calorimetric constant, A is the area under the curve. The calorimetric constant may vary from instrument to instrument and can be determined by analyzing a well-characterized sample with known enthalpies of transition. How glass transition temperature be studied using DSC. The glass transitions occur when the temperature of an amorphous solid is increased. These transitions appear in the baseline of the recorded DSC signal and is due to the sample undergoing a change in heat capacity without any formal phase change. As the temperature increases, an amorphous solid becomes less viscous, that is free flowing, and at some point its molecules gets freedom to spontaneously arrange themselves into a crystalline form. This is known as the crystallization temperature, abbreviated as TC. The transition from amorphous to crystalline solid is an exothermic process and results in a peak in the DSC signal. As the temperature increases, the sample eventually reaches its melting temperature Tm. Melting process results in an endothermic peak in the DSC curve. The ability to determine transition temperatures and enthalpies makes DSC an invaluable tool in producing phase diagrams for various chemical systems. How DSC technique helps in chalcogenide glass studies. Chalcogenide glasses have wide commercial applications such as switching, optical memory devices, and xerography because of their behavior as phase change material. Thermal characterization behavior of bulk chalcogenide glass has been studied widely by DSC technique under non-isothermal conditions at different heating rates, and the curves were plotted. With the help of these thermograms, glass transition temperature Tg, crystallization temperature Tc, and melting temperature Tm were determined through DSC technique. How DSC technique helps in studying chalcogenide glassy alloys, thermal stability and crystallization kinetics on chalcogenide glassy alloys were investigated by employing these alloys to differential scanning calorimetric technique at different heating rates under non-isothermal conditions. DSC studies on thermal parameters of these alloys such as glass transition, onset crystallization and peak crystallization temperatures helped in explaining the nature, composition and behavior of the alloys. What can be deduced by DSC studies on chalcogenide glassy alloys containing bismuth? Double crystallization peaks in the DSC thermogram of the glassy alloys containing bismuth referred to the instability and phase separated network in the glasses. Various kinetic parameters such as thermal stability, enthalpy entropy, specific heat and fragility index were deduced. The calculated kinetic parameters suggested that with the increase in the concentration of bismuth, the stability of glassy samples decreases. The activation energies of glass transition and crystallization was calculated using relevant kinetic formulae. It also opened gate for discussion on the kinetics of the chalcogenide synthesized materials for their applications in phase change memory material. Explain crystallization process in ternary component chalcogenide glasses using DSC studies. DSC studies of crystallization kinetics of ternary component chalcogenide glasses at different heating rates was performed to study crystallization. The alloy exhibited overlapping of exothermic peaks, which on deconvolution using Gaussian fitting of two peaks made it possible to study the crystallization phases separately. The glass transition activation energy Eg and the crystallization activation energies for the first and second crystallization peaks EC1 and EC2 could be identified. The determined kinetic parameters made it possible to postulate the type of crystal growth in the crystallization, the phases at which the alloy crystallizes after the thermal process was further identified by XRD. The diffractogram of the transformed material indicated the presence of microcrystallites of ternary component with the remaining additional amorphous matrix. What is the instrumentation required for DSC experimentation? It is a simple and commercially available instrument. It comes in two types, heat flux type and power compensation type. The heat flux DSC comprises the sample and the reference holder. You can see here in the figure. The heat resistor, the heat sink and the heater. Explain the heat flux DSC and power compensation DSC. Heat flux DSC is a technique in which the temperature of the sample unit formed by a sample and reference material is varied in a specified program, and the temperature difference between the sample and the reference material is measured as a function of temperature. Power compensation DSC technique is one in which difference of thermal energy that is applied to the sample and the reference material per unit of time is measured as a function of the temperature to equalize their temperature, while temperature of the sample unit formed by the sample and reference material is varied in a specified program. How is DSC performed? The experiment is simple. A small amount of sample around 1 to 15 milligrams is placed in a closed crucible in a temperature controlled DSC cell. Another crucible is used for the reference material. The DSC experiment involves heating or cooling of the sample at a controlled and steady rate. The heat flow is monitored as it helps to characterize the phase transitions and or cure reactions as a function of temperature. More involved studies can adopt multi-heating or cooling steps as well as isothermal mode. A modulated DSC technique utilizes temperature modulation to determine weak transitions and separate overlapping thermal events. Does DSC helps in explaining crystalline and amorphous nature of chalcogenide glasses? Yes, the enthalpy relaxations in amorphous materials are described in terms of their heating and cooling rates. Similar relaxations can also be observed from changes in volume and entropies, which is designated as V for volume and S for entropy. What are the advantages of studying DSC on chalcogenide glasses? It helps in determining the physical properties of the glasses, the amorphous and crystalline nature of the chalcogenide glasses, the kinetic parameters such as thermal stability, enthalpy, entropy, specific heat and fragility index of the chalcogenide glasses. It overall helps in determining the composition and the chemical reactions taking place in the chalcogenide glasses formation. The literature that I have cited while making this video is here. You can go through it. Thanks for watching this video till end. Don't forget to subscribe to my channel and also to share this video. Important links on the chalcogenide glasses videos that I have already uploaded is given in the description box.